Hi everyone. Here I'm going to share the result of one of my experiments on Tesla coil, obviously. And in this way, I'm not going to explain how you can produce the secondary coil or recommend which kind of circuit is better. And then only I will focus on the result of my own experiment. Meanwhile, I'm going to use a mini Tesla coil for some concerns, and you will notice why. So I'm not going to use a bit more powerful one. In this experiment, I employ a very simple circuit. Then I use a mini Tesla coil. Then I have a voltmeter on power supply and a milliampere which shows the current on the primary coil of Tesla coil. It is not very accurate because it shows up to 50 milliamp, and I needed to be about 250 milliamp. That's why I made it parallel with a resistor of 0.27 ohms. Then I connect the output of the mini Tesla coil to a couple of high voltage diodes, but I connect these two diodes in opposite direction. And also I have a couple of LEDs here connected in opposite direction. So if I connect to battery, then in this way the red gets on and the opposite direction the blue gets on. So nothing special, and later when the Tesla coil is on, we will see that both of them in the same time are lighted. By the way, I'm going to use salt water and also deionized water in this experiment. And finally, I have a measuring tool for static field detector using MOSFET transistor, very simple circuit. Okay, now let's do the experiment. As you see, the Tesla coil is on, the power supply shows 12 volt, and the milliamp, as I said, doesn't show accurate number, but it's not important for me. I would like to know how the ampere on the primary coil will rise or descend down during the experiment. Now, if I make these couple of LEDs closer to the Tesla coil, you see that both of them get on. Of course, because the output of Tesla coil is AC, so makes both of them on. If I make closer this one, again it gets on. The interesting point is here that if I make this closer to this diode or this diode, both makes this light on. And now, if I make this antenna of the static field detector closer to this diode, it gets off, and this one makes it on. So off, on. Alright, we see that those two LEDs are on. The milliamp shows something, and now if I make shortcut these two high voltage diodes, you see the milliamp shows more current on the primary coil, and those two LEDs get less light. Now if I connect these two alligators to each other, not directly by touching each other, but with using the salt water, doesn't matter. Again, you see that the milliamp rise up and the light of those two diodes gets less. Alright, now I connect with the ionized water and repeat the same. As you see, not only the milliamp descends down, even the light of the circuit gets off, and of course those two LEDs get off because there is no any function on this Tesla coil. Maybe you do the test with the deionized water and then you see that this does not happen, and maybe sometimes you see yes, it does, but sometimes not. So what's the reason? To show you the reason, I use a capacitor. You see that if I connect these two diodes with a capacitor, a similar effect happens and it gets collapsed. But after a while, then nothing. When you see that nothing is happening and vice versa, the milliamp rises more, similar to direct connection, be careful not to touch this capacitor because it may give you a bad shock this way. So this is all, and I hope you enjoyed this video, and please not to forget to like, share and so on. So thank you.